second and last part for that chapter 15, just a highlight on what is very important. Just understand some of the properties. So many aromas and flavors actually come largely from aldehyde and ketone that exist naturally. Some example right here: citronella, cinnamaldehyde, camphor, or silverstone, which is the one that you have actually the musky odor in perfumes, the one we find in the sun gland of the civet cat. Common aldehyde you should know, but formaldehyde need to know their use, properties, and the general formula HCHO. Toxic but very useful. Formaldehyde at room temperature is colorless with a pungent, suffocating odor. As low as 1.1 to even 0.1 ppm in parts per million, you may have eye, throat, bronchial irritation. You can actually get asthma attacks if the concentrations are higher, and you can get dermatitis, which is inflammation of the skin on skin contact. But we use it a lot, even though it can cause serious kidney damage, coma, sometimes death. This is a breakdown product of methyl alcohol, and that's where drinking methanol is so toxic. Another thing that is going to be helpful for you, well, we use it mostly sold at a 37% aqueous solution, and the name is formalin. Why do we use it? Because it's good to kill viruses, fungi, bacteria by just reacting with the amino group that exists in their protein. And so it is used as a disinfecting and sterilizing equipment. Most of the time you need to have a respiratory mask when you use it, even at low concentration. And another form that we actually do use is called paraformaldehyde, which is where formaldehyde polymerizes into a more solid paste. Another important is going to be acetone. You should know the formula CH3CO, CH3, super solvent. Most widely used of all organic solvents, dissolve most organic compound, also miscible in water, meaning that it can just dissolve with the water. Volatile, serious fire and explosion hazard when you let it to evaporate in a closed space. We use acetone as a nail polish remover. There's no chronic health risks that are associated with just once in a while, so casual acetone exposure. And also important, we can actually have that smell when the breakdown of fats and carbohydrate is out of balance. Acetone is then produced in the liver. Looking here at oxidation of aldehyde, you can actually have alcohol, which we saw earlier, that can be oxidized to form aldehyde or ketone. Can follow up with more oxidation of the aldehyde to give you carboxylic acid, which is chapter 17. Now, if you look at the aldehyde oxidation, the hydrogen bonded to the CO, the carbonyl carbon, is replaced by a OH group. Ketones do not have this hydrogen, so they cannot react with oxidizing agent. So, question I may ask you is basic, just what happens if I put an aldehyde with an oxidizing agent? I know I will have a carboxylic acid. What about if I put a ketone with an oxidizing agent? No reaction. So we use those, and because ketone cannot be oxidized with a mild oxidizing agent, we can use those as tests to make the distinction between aldehyde and ketone. One of them is called the Tollens reagent. It's kind of a really cool reagent. It contains silver ion in aqueous ammonia, and when you treat the aldehyde with that reagent, you're going to have here the carboxylic acid anion and the metallic silver, which is the one that's just showed right here covering that Erlenmeyer's flask. Another reagent of importance is called Benedict's reagent. You have blue copper ions, which is going to be reduced to give you a precipitate of red copper oxide in the reaction with the aldehyde. Now just note that Benedict's reagent does not make the distinction between ketones and aldehyde. And at some time we use that Benedict reagent to test sugar in the urine, so it goes from blue to red. Aldehydes are reduced to primary alcohol. Ketones are reduced to secondary alcohol. Those are really the basics for that chapter.